Ever wondered why some stars seem to exist forever while others explode in a brilliant supernova? This isn't some random celestial lottery, there's a fascinating science behind it. You see, a star's lifespan isn't simply a matter of time, but a remarkable journey shaped by its mass. From their birth in vast molecular clouds, through their luminous main sequence, to their grand finale, each stage of a star's life is dictated by its mass. Intriguing, isn't it? The secret lies in their mass. Let's unfold this cosmic mystery. Every star embarks on its journey within a vast molecular cloud. Imagine a space filled with gas and dust, so massive it's beyond comprehension. This is a giant molecular cloud, the womb from which stars are born. These clouds are colossal, spanning hundreds of light years across, and they are the primary ingredient in the recipe for star formation. Now, the birth of a star is not a sudden event, but a process, a dance of elemental forces. Within these molecular clouds, pockets of gas and dust begin to collapse under their own gravitational pull. Picture this not as a violent implosion, but as a slow, graceful contraction. Over thousands of years, these materials come together, growing denser and denser, forming a celestial body known as a protostar. But what exactly is a protostar? It's the embryonic stage in a star's life, a hot, dense mass of gas that has not yet ignited to become a full-fledged star. It's like the caterpillar, not quite a butterfly, but on its way to becoming one. As the protostar continues to accumulate matter from its surrounding cloud, it grows larger and its core becomes hotter. Now, here's where things get really interesting. When the core temperature of the protostar reaches about 10 million degrees, a process called nuclear fusion begins. Hydrogen atoms in the core start to fuse together to form helium, releasing an immense amount of energy in the process. This energy counteracts the gravitational collapse, creating a stable star. This phase, where a protostar transitions into a main sequence star, is akin to a child maturing into adulthood. It's a critical step in a star's life, a point where it has gained enough mass and energy to shine brightly in the night sky. So, from a vast molecular cloud, through gravitational collapse and nuclear fusion, a star is born. It's a fascinating journey, a testament to the grandeur and complexity of our universe. And thus, a protostar, the baby star, is born. The protostar, now in its adolescence, enters a phase called the main sequence. It's akin to a teenager transitioning into adulthood, a stage of growth and stability. But what exactly happens during this main sequence? Let's dive in. At the heart of the star, an incredible transformation takes place. The core's temperature soars to a critical level, and hydrogen atoms, the star's primary fuel, begin to fuse together. This nuclear fusion reaction forms helium and releases an incredible amount of energy. This energy, in the form of light and heat, is what makes the star shine so brilliantly in the night sky. The main sequence is not a quick flash in the pan. Oh no, it's the longest phase in a star's life, spanning millions to billions of years. Just imagine, our own sun has been in this phase for about 5 billion years and is expected to stay in it for another 5 billion. That's a lot of birthday candles. Now you might be wondering, does every star spend the same amount of time in the main sequence? Well, not quite. The mass of the star plays a significant role in determining the duration of this phase. You see, more massive stars burn through their hydrogen fuel at a much faster rate. These cosmic powerhouses have shorter but more luminous main sequences. On the other hand, less massive stars, like red dwarfs, are the tortoises in this cosmic race. They burn their fuel more slowly, and thus they can remain in the main sequence for hundreds of billions of years, much longer than the current age of the universe. This phase of the star's life is incredibly stable. The star has reached a delicate balance between the inward pull of gravity and the outward push of pressure from the fusion reactions. It's a stellar standoff that lasts as long as the star has hydrogen to burn in its core. The star now shines brightly, entering the prime of its life. With its core ablaze and energy radiating out into the cosmos, the star has matured. It's in its prime, stable and shining, ready for the next stages of its fascinating journey. As the hydrogen fuel exhausts, the star embarks on its journey towards becoming a giant. This is no ordinary growth spurt. It's a transformation of cosmic proportions that propels the star into its giant phase. The star, once a compact ball of burning hydrogen, begins to swell, expanding to many times its original size. This swollen state signifies the star's evolution into a red giant, or for the more massive stars, a supergiant. But what triggers this dramatic change? It's all down to the star's core, where the real magic happens. As the hydrogen fuel depletes, the core contracts and heats up. This intense heat triggers a new round of nuclear reactions, leading to the fusion of helium atoms. This helium burning process forms heavier elements such as carbon and oxygen. Yet, the star's transformation doesn't stop there. As the helium fuel exhausts, the outer layers of the star begin to drift away, expelled into the vast expanse of space. This expulsion paints a breathtaking picture across the cosmos, a testament to the star's long and fiery life. This giant phase, however, is but a stepping stone in the star's life cycle. It's a pause, a deep breath before the star embarks on the next chapter of its cosmic journey. Our star, now a giant, is nearing the end of its life. What follows next is the star's grand finale, a spectacle of cosmic proportions. As the star exhausts its hydrogen fuel, it undergoes a dramatic transformation, either forming a planetary nebula or exploding in a supernova, depending on its mass. Imagine a star up to about 8 times the mass of the Sun. Its outer layers are expelled, painting a breathtaking picture across the cosmos, a shell of gas known as a planetary nebula. The once mighty star, now a faded shadow of its former self, leaves behind a core, a white dwarf. This dense remnant is what remains of the star's core, a silent testament to its once vibrant life. On the other hand, the fate of more massive stars is even more dramatic. A supernova explosion occurs, a burst of energy so powerful it can briefly outshine an entire galaxy. This celestial fireworks display is a fitting end to the life of a star that has shone brightly for millions, sometimes billions of years. But what happens to the core of such a star? It collapses under its own weight, forming either a neutron star or a black hole. A neutron star is an incredibly dense object, composed mostly of neutrons. Imagine an object about the size of a city, but with a mass greater than that of our Sun. For the most massive stars, their cores can collapse further, forming black holes. These are regions of space-time where gravity is so strong that nothing, not even light, can escape. They are the ultimate cosmic mysteries, the final act in the drama of a star's life. The lifespan of a star, from its humble beginnings in a molecular cloud to its grand finale as a white dwarf, neutron star, or black hole, is a journey of cosmic proportions. It's a journey that can take millions to billions of years, and it's all determined by the mass of the star. The star, having lived a full life, leaves behind a cosmic wonder. This is the grand finale of a star's life, a spectacle that reminds us of the vast, beautiful, and ever-changing universe we live in. From birth to death, the life of a star is a cosmic journey of epic proportions. The lifespan of these celestial beings is a grand narrative, written by the hand of mass and gravity, and narrated by the language of light and heat. Our story begins within the vast molecular clouds of gas and dust, where gravitational forces conspire to create a protostar. This marks the formation stage of a star's life, the first chapter in an epic tale that spans millions to billions of years. As the core temperature of the star intensifies, hydrogen atoms merge to form helium, releasing energy in a process known as nuclear fusion. This is the main sequence stage, the star's prime of life, where it shines brightest and longest. How long a star stays in this stage is determined by its mass, but like all good things, this too must come to an end. As the star exhausts its hydrogen fuel, it expands, transforming into a red giant or a supergiant depending on its mass. During this phase, the outer layers of the star are expelled into space, and helium fusion occurs in the core, birthing heavier elements like carbon and oxygen. The final act of a star's life can take two dramatic turns. For lower mass stars, the outer layers are expelled, creating a beautiful shell of gas known as a planetary nebula. The remaining core becomes a white dwarf. For more massive stars, a supernova explosion occurs and the core collapses to form either a neutron star or a black hole. The fate of the remaining core is again determined by its mass. A low to medium mass core becomes a white dwarf. A more massive core becomes a neutron star, an incredibly dense object composed mostly of neutrons. The most massive cores can collapse further to become black holes, regions of space-time where gravity is so strong that nothing, not even light, can escape. The next time you gaze up at the night sky, remember each star has a story, a life, dictated by its mass.